Which species has 90-degree bond angles? The options are CO3 2-, next is PCl3F2, the next is SiCl4, and the last is IF5. So students, let's draw the structures of the given compounds, and then we'll be able to find out that in which compound or in which species there is a bond angle of 90 degree. Starting with CO3 2-, C double bond O, O minus, O minus. So the bond angle is around 120 degree each. Moving to next option, which is PCl3F2, phosphorus, 3 chlorine and 2 fluorine at the axial position. Here the bond angle between fluorine and chlorine is 90 degree. Moving to next option, which is SiCl4. Here the geometry is trigonal planar, here it is trigonal bipyramidal, and in case of SiCl4 the geometry is tetrahedral and the bond angle is 109.5. Moving to next option, which is IF5. The hybridization is sp3d2. I has 1 lone pair and 5 bond pair. Here the geometry is square pyramidal. Because of this lone pair, the bond angle has slightly deviated from 90 degree. That means the species which has 90 degree bond angle is number 2, that is PCl3F2. That means the correct answer is option number 2. Moving to next question, students, which is 87. Species which does not contain sigma bond is. The options are O2, C2, F2 and N2. First of all, in this question, students, we need to write the molecular orbital configuration, and then we'll be able to find out that which species do not have sigma bond. Starting with O2, number of electrons are 16. So sigma 1s2, it is sigma star 1s2, sigma 2s2, then sigma star 2s2, then we have sigma 2pz, then we have pi 2px, pi 2py, 2, 2, 2, pi star 2px1, pi star 2py1. Here the bond order is 2. That means O2 has 1 sigma bond and 1 pi bond. In case of C2, the total number of electrons are 12. Sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2. Then we have pi 2px2 and pi 2py2. Class, in this case also the bond order is 2. But there is no sigma bond, as the number of electrons in sigma 1s, sigma star 1s, sigma 2s and sigma star 2s cancel out each other. The only electrons which contributes in bonding is present in pi orbital. So the bond order 2 is because of the electrons in the pi orbital. So in C2, both the bonds are pi bonds and there is no sigma bond. On the other hand, in case of F2, there is one bond, as the bond order is 1, and that bond is a sigma bond. On the other hand, in case of N2, we have already discussed, the bond order is 3, and out of those 3 bonds, 1 is sigma and 2 is pi bonds. So the correct answer for this question is option number 2. That means C2 has no sigma bonds. Both the bonds in C2 are pi bonds. So the correct answer is option number 2. Moving to next question, students, which is 88. Which of the following does not form intramolecular hydrogen bonding? Student, when the hydrogen bonding exists within the same molecule, it is known as intramolecular hydrogen bonding, and when it exists between 2 different molecules, it is known as intermolecular hydrogen bonding. Let's find out in which molecule intramolecular hydrogen bonding does not exist. Starting with number 1, which is chloral hydrate. Class, generally we know that chlorine does not participate in hydrogen bonding, but in case of chloral hydrate, there exists hydrogen bonding between chlorine and hydrogen, and this is known as intramolecular hydrogen bonding. Moving to next option, which is orthonitrophenol. OHNO2, there exists hydrogen bonding. Moving to next option, there also exists hydrogen bonding. Moving to last option. In this molecule, there is no intramolecular hydrogen bonding as the two substituents are attached at the para position of each other. Rather, in this molecule, there exists intermolecular hydrogen bonding. So, the correct answer is option number 4. Moving to next question, students, which is 89. Correct set of order regarding bond length is the bond length of O2 greater than O2 plus. The bond length of O2 2 plus is greater than O2 2 minus. The bond length of O2 2 minus is greater than O2 minus. Student, as we all know that as the bond order increases, the bond length decreases. So, we need to calculate the bond order of the given species, which we can calculate using molecular orbital configuration. I am writing the bond order. The bond order of O2 is 2. The bond order of O2 plus is 2.5. The bond order of O2 2 plus is 3. The bond order of O2 2 minus is 1. And the bond order of O2 minus is 1.5. So the correct order of bond length is order of bond length is O2 2 minus followed by O2 minus followed by O2 further followed by O2 plus, and the least bond length is observed in O2 2 plus. So let's find out which is the correct order. O2 greater than O2 plus. This is the correct order. Then O2 2 plus greater than O2 2 minus. Students, it is very clear that O2 2 minus has the largest bond length. So this is an incorrect order. O2 minus less than O2 2 minus. Student, this is again a correct match as O2 2 minus has the largest bond length. So the correct answer for this question is A and C only. That means order in A and C are correct. So the correct answer is option number 2. Moving to next question, which is 90. If the observed dipole moment of HBr is 0.78 d and the distance between atoms is 142 picometer, then percentage ionic character of HBr bond will be. As students, as we all know that percentage ionic character is equals to mu observed upon mu theoretical into 100. Since observed dipole moment is given, we have to calculate. So the theoretical dipole moment we have to calculate. So mu theoretical is equals to Q into D. The value of Q is 4.8 into 10 to the power minus 10 ESU multiplied by 142 into 10 to the power minus 10 centimeter. As the distance is already given in picometer, we have to convert it into centimeter, which is equals to 142 into 10 to the power minus 10. Also, we have taken the charge in ESU, which is the basic unit of charge, which is ultimately equals to, class, I'm solving it a bit, 10 to the power minus 18 ESU centimeter. Now, percentage ionic character is equals to mu observed upon mu theoretical into 100. Student, here the mu observed is given in D, and as we all know that 1D is equals to 10 to the power minus 18 ESU centimeter. So the numerator becomes 0.78 into 10 to the power minus 18 ESU centimeter divided by mu observed, which is equals to 4.8 into 1.42 into 10 to the power minus 18 multiplied by 100, which is equals to 0.78 divided by 4.8 multiplied by 1.42 into 100, which is equals to 11.4%. That means the correct answer for this question is option number 2. Students, that was my last question. Thank you so much.